So in this problem, we need to determine the equation of a circle such that the circle is tangent to a line given by the equation 2x minus y plus 1 equals to 0. Also, it is tangent at that particular point which is given to us 2 comma 5, and we have the center lying on the line x plus y equals to 9. So let's try to understand this problem graphically. So let's say we have a circle, and then at the point, let's take it as 2 comma 5. So at this particular point we have a tangent. So where this is the tangent to the circle at the point 2 comma 5, and the tangent has an equation given by 2x minus y plus 1 equals to 0. We have another piece of information provided to us. We have the center of the circle, so let's denote it by C, and we have that another line passes through the center of the circle. So let this be another line, and this line has the equation x plus y equals to 9. Using this information, we need to obtain the equation of the circle. Now to begin with, to find out the equation of a circle, we only need two information. One is finding the coordinate of the center, and then we need the radius of the circle. Because we are going to use the standard form, let's quickly go through the standard form of a circle. So let's say we have a circle whose center has the coordinate h comma k, and the radius is given by r. Then the standard form of the circle is given by this particular equation, which is x minus h whole squared plus y minus k whole squared equals to r squared. Now in the case, we do not have the coordinate of the center, and also we do not have any information about the radius. So that means our goal will be to find out the coordinate as well as the radius. So let's begin. So what we'll do it, we'll start by first constructing a perpendicular from the center of the circle to the tangent line given by 2x minus y plus 1 equals to 0. So this is going to be a perpendicular line. So let's say that it meets the line at the point, let's call it A. So that means here we are doing a construction here. The construction being CA is perpendicular onto the line. So we're going to denote the equation of the tangent line with L1 and the equation of the line passing through the center with L2. So here we have CA perpendicular to line L1. Fine. Now let's start with the line equation L1. It's given here that this is 2x minus y plus 1 equals to 0. Now let's rewrite this equation. So we'll keep y on the left hand side and transpose everything to the right hand side. So we'll get 2x plus 1. The reason why we're writing in this particular fashion, because we know the slope intercept form. The slope intercept form is given by y equals to m times x plus c, where m represents the slope of the line and c is the y-intercept. So if we compare it, we immediately get the value of the slope. So our slope comes out to be equals to 2. So the slope of line L1, so we're working with line L1, has a slope of 2. The reason why we obtain the value of this slope, because we know that CA, the line CA is perpendicular to L1, and whenever we have two lines perpendicular to each other, the product of the slope is always -1. So let's suppose let the slope of the line CA, that it be denoted by M1. Then we have the case that the product M multiplied to M1 will be always equals to -1. Since we have obtained the value of M, so we can also find out the value of M1. So this is going to be equals to -12. Now that we have the slope and we also have one coordinate point A, we can use the one point slope form to find out the equation of line CA. So let's first state the 1 point slope form. So let's say we have a point having the coordinate x1 comma y1, and let's say line passes through this particular point which has got a slope of m. Then the equation of this line is given by y minus y1 equals to the slope multiplied to x minus x1. So this is referred to as the 1 point slope form. In our case, we have one point A. So our point A is 2 comma 5, and then through this point we have the tangent line passing through it. This has got a slope of 2, and we have another line CA which is perpendicular to this line. So this line we call it CA. So CA has the slope of -r. We are interested in finding out the equation of line CA. So that means using the 1 point slope form, equation of line CA. So that will be equals to y minus y1. So y1 will correspond to the point A. So point A is 2 comma 5. So let me note it down here. So that means we have y minus 5 equals to negative half multiplied to x minus x1, which is x1 is 2. So let's solve this. We get 2 times y minus 5 equals to negative of x minus 2. We get 2y minus 10 equals to negative x plus 2. Combining them, we get x plus 2y equals to 12. So this is going to be the equation of line CA. Now that we have the equation of line CA, we also have the equation of the tangent line. So if we solve the two equations, it's going to give us the value of x and y, which is actually the intersection point of A. So let's try to solve the equation L1 and the equation for line CA. So we have the equation of the tangent line 2x minus y equals to negative 1. We're going to label it as equation number 1. And then we have equation of line CA, which is perpendicular to line L1. So that's x plus 2y equals to 12. So what we'll do, we'll use the method of elimination first to eliminate y. So let's take equation number 1 and multiply each terms with 2. So we're going to get 4x minus 2y equals to negative 2. Then we'll take equation number 2 and keep as it is. So this is going to be x plus 2y equals to 12. So let's add the two equations. So 4x plus x is going to give us 5x. 2y and negative 2y is going to cancel out, and 12 minus 2 is going to be 10. So x value comes out to be 10. Now that we have the value of x, we can use it to eliminate to find out the value of y by using the method of substitution. So we can use either equation 1 or 2. Let me use equation 1. That means we have 2 times 2 minus y equals to negative 1. So we have 4 minus y equals to negative 1. So y will be equals to 5. So we have found out x as well as y. So x comma y, which is the coordinate of point of A, so that comes out to be equals to 2 comma 5. So we have obtained the coordinate of point A. Now our next task will be to find out coordinate of the center or the coordinate of point C. That's very simple because we have equation of the line CA and we also have equation of line L2. So that means solving L2 and the line CA. So this I'm leaving as an exercise for you to try out. So the x coordinate comes out to be equals to 6 and the y coordinate comes out to be equals to 3. So that means we have now obtained the value of the coordinate of C. So that's 6 comma 3. Fine. Now that we have the coordinate of the center, we can also find out the radius r. So a radius r is simply the length CA. Here we'll have to use the distance formula. So we'll take the square root, and underneath the square root, first we will take the square of the difference of the x coordinate. So we have 6 minus 2 whole square added to the difference of the square of the y coordinate. So that's 3 minus 5 whole square. So let's solve this. We're going to get square root of, so 6 minus 2 is 4. 4 squared is 16. Plus 3 minus 5 is negative 2. Negative 2 squared is 4. So that means we have square root of 20. This is our radius. Now that we finally have the radius, which came out to be square root of 20, we have the coordinate of the center. We are ready to find out the equation of the circle. So we will note down the standard form. So the standard form, which is given by x minus h whole squared plus y minus k whole squared equals to r squared. Now in our case, our center, we have obtained that is simply h comma k. So this came out to be equals to 6 comma 3, which implies that the value of h is going to be 6 and the value of k is going to be equals to 3. And we have also found out the radius, that's equals to square root of 20. So we can substitute this into our formula to finally get x minus 6 whole squared plus y minus 3 whole squared. And this will be equals to the square root of the radius, so that's 20 units. So this is going to be the equation of a circle.